let's consider f of x equaling this polynomial, where we have the binomial x minus 2, but then that's being multiplied by the binomial x minus 7, that quantity squared. So technically, 2 of those are showing up. And then we have 3 of the x plus 8. Problem is, we can't have more than one intercept at a single point. So what we say is f of x has zeros at x equals 2 with a multiplicity of 1, meaning it only shows up one time in that equation. X equals 7 with a multiplicity of 2. And x equals negative 8 with a multiplicity of 3. What do we mean when we say multiplicity? It's how many times that 0 or its factor is in the equation. I use EQN for short for equation. So the x minus 2, that zero's factor only shows up once. The x minus 7, technically there's 2 of those, and then there's 3 of the x plus 8s. Now, how does this help us? Is the multiplicities of the zeros help us figure out the behavior at that x-intercept. Graphs of multiplicity, even multiplicities behave like an x squared, like an even polynomial. Remember, those are parabolas. So they bounce off the x-axis. So an example would be if you had this graph, that 0 has even multiplicity. If it has an odd multiplicity, it behaves like an odd polynomial, like this guy, and they cross through the x-axis. Now, with the odd multiplicity, the higher the multiplicity, the flatter the graph is at the 0. So for example, you might have an x-intercept here and an x-intercept there. So this has an odd multiplicity, could be 1, but this has a higher odd multiplicity. It could be 3.